Hello viewers, and welcome once again to my YouTube channel. In this video I'm going to provide you the solution to this interesting question. We are asked to solve for n. This question involves single factorial and then double factorial. In solving for n, I am going to apply the key points I have highlighted here. Let's go through them one by one. How do we expand n factorial? It is n times n minus 1 times n minus 2 and so on and so forth. That is, each time we are subtracting 1 from the number. To expand n double factorial, it is n times n minus 2 times n minus 4 and so on and so forth. That is, each time we are subtracting 2 from the number. For example, if you're going to expand 7 double factorial, it is 7 times 5 times 3 times 1. Okay, now the third key point here is that n factorial over n double factorial is the same thing as what? N minus 1 double factorial. So let's go on to solve this question for n. How do we solve for n? Can you notice that we have n factorial over n double factorial here? It is the same thing as what? N minus 1 double factorial. So I am going to replace the whole of this with what? N minus 1 double factorial, and I will divide that by the n minus 5 double factorial we have in the question. So this equals what? The 48. What do we do next? We are going to expand this numerator or this denominator, but the one we are going to expand is the higher one. N minus 1 is higher. Now in expanding this, we are going to obey this second key point there. That will be n minus 1. You know, we are subtracting 2 each time. Subtracting 2 from this, the next one is going to be n minus 3. Subtracting 2 again, the next one is in the expansion is going to be n minus 5. Are we going to go on with the expansion? No. Let's end the expansion here so that it will cancel this denominator. The expansion for this is the same as the expansion for this. So we are stopping it there so that they would cancel out. So what is now left is equal to 48. What do we do next? Let's expand what we have here. If you expand that, n times n, that is n squared minus 3n minus n plus 3 equals 48. Collecting our like terms, we're going to have n squared minus 4n. When the 48 crosses here, that gives us minus 45 equals 0. So this is now a quadratic equation that we're going to factorize. Our factors are going to be 5 and 9. Our factors are going to be 5 and 9. So factorizing the first one gives us n into n plus 5. Factorizing the second one gives us minus 9 into n plus 5 equals 0. So from the two brackets we have there, we're having n minus 9, n plus 5 equals 0, and our n will equal to 9 or minus 5. But then, which answer are we going to report from here? Remember, in the question we are told that n has to be a natural number. Natural number begins from 1 and above. They are positive numbers. So we're going to report our n as equal to 9. Now let's check if this answer is correct. Let's plug it into the original question. The original question is n factorial over n minus 5 double factorial and then n double factorial again. So n factorial is 9 factorial. N minus 5 double factorial, 9 minus 5 there, that is 4 double factorial, and then 9 double factorial again. So pressing the calculator, what is the value for 9 factorial? You would have 362,880. The value for 4 double factorial, that is 4 times 2, which is 8. The value for 9 double factorial, that is 9 times 7 times 5, and so on. So that will give you 945 if you simplify further. So dividing all this together gives us the what? The 48. So it shows that our n is equal to 9. Thank you for viewing. For more exciting videos like this, kindly subscribe to my channel and share my videos.